Hi there, grade 10s. These questions I would like to work through now is question number 1 in a physics paper. So what I'm going to do is I'm going to work through these questions. You have 4 options as answers, and only one can be correct. The first question, question 1.1. In which one of the following are the electromagnetic waves ordered from the highest to the lowest penetrating ability? Now, penetrating ability has to do with energy, and the energy of electromagnetic waves is directly proportional to their frequency. If you look on the data sheet, there is an equation, E equals H, which is representing Planck's constant, times the frequency. Now, if we look at the spectrum, the longest wavelength waves would be radio waves. And it goes to the shortest wavelength, which is gamma rays. And if we look at the wave equation, C equals lambda times frequency, where C is a constant, 3 times 10 to the power 8 meters per second, then I can see from that wavelength is inversely proportional to frequency. So the waves with the shortest wavelength has the highest frequency, where the waves with the longest wavelength has the lowest frequency. So to order them from the highest to the lowest penetrating ability, we have radio, micro, infrared, visible, UV, X-rays, and then gamma rays. So visible, radio, microwave is already in the wrong order, so that one's not an answer. Infrared, ultraviolet, gamma rays, wrong order. X-rays, infrared, microwaves, that goes from X-rays to infrared to micro in that order, which is from the highest frequency to the lowest frequency. So from the highest penetrating ability to the lowest penetrating ability, I would say that is the answer. This one jumps around to different answers. So number C is the answer there. Next one. Number 2. In a moving car, I guess I must go this way. Just clear all. In a moving car has a kinetic energy, EK. If it speeds up 4 times, speeds is multiplied by 4. How much kinetic energy does the car have? To answer this question, I need to know what the equation is to calculate kinetic energy. It is a half times mass times speed squared. Now, the mass of the car would stay relatively constant. We take that as constant, and a half is a constant. So the kinetic energy of the car is directly proportional to the speed of the car squared. Now, if the speed, which is v, speeds up 4 times, then this v is 4 times what it was, but that 4 times must be squared with the v. What happens if you square a 4? It becomes a 16v squared. So if originally kinetic energy was directly proportional to v squared, now the new kinetic energy is 16 times what it was. Right? So that answered question 1.2. Question 1.3. Let me just clear this. You are really welcome to stop the video any time just to catch up. Question 1.3 is an electrostatic question. It says, two isolated metal spheres R and S have charges of +3, 10 to the minus 6 coulombs and plus 1.6, 10 to the minus 6 coulombs, as shown. Now, if it's got a positive charge, it has lost electrons. Now, the more positive charge has lost more electrons. So it's got less electrons. So between +3 and plus 1.6, plus 1.6 is the smallest, the smaller positive charge. So it has more electrons. Right, let's look at the answers, the possible answers. R has more electrons than S. I've just answered that question. That's nonsense. If the two spheres are brought together to touch, electrons will flow from S to R. Because S has a smaller positive charge, it has more electrons than R. So B is an answer. Let's just double check the examiner here. If the two spheres are brought together to touch, the positive charge will flow from R to S. A positive charge will never move. The positive charge originates in the protons. So a positive charge will never move. They're in the nucleus of the atoms. So that's also not true. And the force of R on S is to the left. Now, that can't be possible because R will repel S. R repels S. So that would be a force to the right. So number D is also not a possible answer. Number 1.4, the equivalent unit to the ampere is. Now, to figure out this question's answer, I need to go to the equation on the data sheet that we can use to calculate electric current strength. Now, by definition, electric current is the rate of flow of charge. So the equation is I equals Q over T, delta T. You could write it in a different way, but we want to know what the ampere is. So I want the subject of the formula to be current. Now I know that current is measured in ampere. The unit for charge is the coulomb. The unit for time is the second. If I use my mathematics and change the division sign to a multiplication sign, it is coulomb per second. So this answer is D. My advice is whenever they ask a question where they want the equivalent unit is to go to the equation that originates from the definition of the quantity. Right. Question 1.5 is about vectors. Which one of the following contains both a vector, so it's got size and direction, and a scalar, which got size only? Weight is a force, so it's a vector. Velocity is the rate of change in position. It is a vector. So both in A would be vectors. Mass is a scalar. Charge has no direction connected to it, so it is also a scalar. So B is not an answer. Speed is the distance traveled per unit time, so that is a scalar, no vector. And acceleration is the rate of change in velocity, which is a vector. So C is the correct answer here. Distance is a scalar, the path length, and energy is also a scalar. Right, the last question is question 1.6. And we have here the characteristic property of motion at constant velocity. If it's constant velocity, its displacement per second is the same. Right, if I can explain it this way, if you travel at a constant velocity of 60 kilometers per hour north, then you will cover 60 kilometers in every hour you travel. Let's look at the options. A change in position per unit time is constant. Change in position and displacement is the same thing, so it looks like that is the answer. Let's check the others. A change in velocity per unit time is constant. No, it will be zero because we're going at constant velocity. There is no change in velocity. The acceleration remains constant. Well, if you have no change in velocity, you have no acceleration. So it is also zero. And if the quantity is taken as zero, it is zero, then it's not taken as constant. The change in position per unit time increases at a constant rate. That defies number A. So number A is the answer. I will work through this question paper question by question. So next video will be on question 2.